Is Mrs. John with lesson 1, which for year 12, an introduction to electromagnetism. What is electromagnetism? Electromagnetism is the study of the relationship between electric currents and magnetic fields. What is a magnetic field? It is the area around a magnet where another magnet or a magnetic material, which could be iron, nickel, or cobalt, would feel a force. Now, these magnetic fields are represented by field lines, and this is the field lines around a bar magnet. And just remember, the direction of the magnetic field is the direction in which a north pole would move, and because opposite poles attract each other, you need to have the lines going from the north to the south. So they leave the north pole and they enter the south pole. And you will see that the concentration of the field lines is an indication of where the magnetic field is the strongest. So the magnetic field is the strongest at the poles. The earth itself behaves like as if there was a huge magnet in it. So you have the similar shape, but the earth's magnetic field has a geographic north aligned to the magnetic south, and the geographic south aligned to the magnetic north. Now, you have a uniform magnetic field in two places, and a uniform magnetic field is identified by evenly spaced parallel lines, and they exist between opposite poles of a magnet, and it also exists inside a solenoid. And just remember, the direction of the field goes from the north to the south. And over here, outside the solenoid, the magnetic field goes from north to south, but inside it goes from south to north because these lines are continuous. Now, you also need to know that there is a magnetic field whenever there's a current flowing through a wire. If the wire is straight, the strength of the magnetic field at some distance away is given by B is equal to Ki over D, where K is 2.0 times 10 to the power of negative 7 Tesla meters per amperes. And you can use the right-hand grip rule to find the direction of the current or the direction of the magnetic field. The thumb indicates the direction of the current. The way the fingers are curving indicates the direction of the magnetic field, and that will be okay for if it's a straight wire. But if the wire is very long, you need to roll it up and it becomes a solenoid. In the solenoid, you looked at the curved line ones where the current is flowing through. So your fingers will represent the current, and the thumb, whichever way it's pointing, will indicate where the north pole is. So your thumb would have pointed this way. And when you curve your fingers, let me see that, going down, your thumb is here. So there's your north pole, there's your south pole. All right.